Hello folks, this is Jeffrey Bale. My call sign is NT1K, and today we're going to look at the miniVNA Pro by Mini Radio Solutions. Past couple YouTube videos I've used this unit to measure a one-to-one current balloon and a low-pass filter. Since then I've received a couple questions regarding the unit, so I figured it would be nice to make a little video here showing all about the miniVNA, and we're actually going to do a fresh installation as well as a first calibration of the unit. So, for those who do not know, it's basically a handheld vector network analyzer. I would say it's a hobbyist grade level. Um, I'm not too fluent with test equipment, but for the ham radio operator, it's a great device to measure antennas and other RF circuits. Um, what's really great about this unit compared to like the MFJ or UKITs or stuff like that this is truly wireless. This is truly wireless. It uses Bluetooth. You do not you have the option not to have it tethered to a computer. So this allows you to, like, for example, to have this on the end of your feed line or at the end of your coax and make adjustments at the antenna and see the measurements at the feed line or at the feed point. You don't have to keep going back and forth making adjustments. You can use, there's even an Android application developed for this unit that allows you to use your smartphone or your tablet to view the data coming from the unit. So I think that's pretty neat. The unit measures about a little under 5 inches long by about 3 inches wide. It's a nice small unit. The case is made of a translucent plastic. It's an elliptical shape with rubber grips. We have a DUT and DET port here that allows you to measure S11 and S21 values. On the other end, we have a USB port here, a little switch to turn the unit on and on. It does have a internal battery. We have an accessory port, and we have a function button here. This this little unit here, just this unit, can measure from it has a frequency range of approximately 100 kilohertz to about 200 megahertz. With the accessory port, you can add on a device called the extender, which will bring you up into the gigahertz region, 1 point or something like that. I never really looked into the extender, so that's the unit. I also have the calibration kit here, which consists of the calibration transmission loop. I have an SMA open stub. There's no center conductor. I have a 50 ohm load for calibration, as well as a shorted stub here, shorted SMA connector, which puts the center conductor to shield. I also have some other adapters that I always keep with the unit. I have a binding post here, the binding post to BNC. I have another 50 ohm load that I use to like quadruple check myself, and I have some SMA to like BNC and a PL259 adapter, and as well as this little Bluetooth module right here. This allows me to use my desktop or my laptop if my laptop doesn't have Bluetooth. It allows me to still use this wirelessly with a desktop or laptop computer. I would get a quality one. I got the cheap one here, but I would get a quality one that gives you a little better range. Supposedly the range of the miniVNA is about 100 meters. I have not tested that part out yet, but it does work wirelessly. Um, at least line of sight. I'm not sure how it works through walls and stuff like that, but someday I'll give that a test, or someday soon I'll give that a test. So there's the unit. We're also going to look at the software, and we're going to do an installation as if we were the first time taking the unit out of the box. The first thing I would do before even hooking this up to your computer in any way is to make sure your drivers are up to date for Java, and make sure Java's up to date and your FTDI drivers are up to date. I can't stress that enough. I think people have issues with hooking this up and getting it recognized is because they don't have the drivers installed, or they're using outdated or the wrong drivers. So you want to go to the FTDI's website and just make sure you have the latest and greatest drivers. I've read the reviews on the miniVNA Pro, and some people had issues with it being recognized on 64-bit systems or Windows 7. I've had it successfully run on Windows XP. I have had it successfully run on Windows XP 64, Windows 7, Windows 7 64, as well as Windows 8.1. So I was able to recognize this on all platforms, and I've had almost zero issues with that in regards to that. You can get the software for the miniVNA through the Mini Radio Solutions website. The software is called VNA/J, and I got it right here. It's just a jar file. It does use Java, and so that's why I suggest to have all your Java files or everything up to date. So the computer I'm using is a Windows 7 x64. It's an AMD processor, quad core, and it's a 5-year-old computer. It shows you that it still works even with a 5-year-old computer. I know there's some ham radio operators that probably still have Windows 95 in their system, but I would try to at least stay up to date as much as possible when it comes to gadgets like this. So I deleted all the files that were associated with this. So all I have right now is just the VNAJ file, the jar file that I downloaded from the website. As of mid-March, we're using VNAJ 2.8.6F. So what we're going to do is double-click on it. And then, of course, it loads in another screen. So let's bring the screen over here. And you'll know a little warning popped up saying it's uncalibrated. And you'll see this red little uncalibrated box here. So the first thing we want to do, though, is have the software recognize the analyzer. So I am going to shut the software off because I've learned to hook up the miniVNA before turning the software on. It makes life a little easier. So let's take our USB port and hook it up. And let's reload the software. And we're going to try to get dragged back into this window here. There we go. And what I like to do before trying to hook it up is I want to bring up, with Windows 7, you can bring up the devices here. And you'll notice that as soon as you plugged in the device, this little thing pops up. I'm not sure if it will be the same on your computer, but it's the F232R USB UART port. And I'm going to go to right-click it and hit Properties, or double-click it and go to the Hardware tab. And I notice it's hooked up to COM port 2. It's using the FTDI chip. So I just want to make sure it's using COM port 2. Then we're going to go to the go back to the VNAJ software. We're going to go to Analyzer, and we're going to go to Setup. Another box pops up. And you'll notice that it defaults to sample and sample dummy port. This allows you to use the software without a device hooked up. So if you wanted to try the software and navigate around it before you even have the miniVNA Pro or any of these other devices, you're allowed to do that. So we're going to choose the miniVNA Pro, and you'll notice it says available ports COM 1 and 2. So we know the device is hooked up to COM 2. We're going to click on highlight COM 2, and we're going to hit Test. And if everything goes well, you'll see a green box pop up in the status. Yep, selected driver and port are working. Please press Update. So there we go, Update. And there's a warning I got when I first loaded the software. No calibration data available for mode, because we haven't calibrated the unit yet. So we're going to hit OK. The second thing we want to do, or third, fourth, I'm not sure what step I'm on now, but next thing we want to do is create a calibration file for it. So we're going to hit Create, and another window pops up here. And you'll see that it's read open, read short, reload, and you'll see that read loop is not active because we're not in transmission mode right now. We're in reflection mode. And you know you're in reflection mode because it defaults to reflection mode when you start up the software. So we're going to start from left to right. It says leave. It says leave the DUT and DET port open. But I got this open calibration stuff here, so we're going to screw it to the DUT port. There we go. And we're going to read it. All right, let's stop it from sliding off my table here. I have it in a weird position. So let's do that. Takes a couple seconds. There we go. That sort of looks like how the graph shows in the manual. If you see something different from that, there might be either an issue with RF getting in, or there might be an issue with the box itself, but I haven't had that problem yet. Next one, it says read short, connect to 0 ohm load. We'll do that right now. This is the shorted adapter here. Let's hit read short. Put the unit down. There we go. That sort of looks like how it's shown in the manual. And then we're gonna, it says read load, connect the 50 ohm load to the to the unit, to the DUT connector. Okay, and we're gonna hit read the load. And there we go. The unit's now calibrated. You can make the calibration more accurate by increasing the scans and calibration steps. So if you have the scans to set to like 2 or 3, it will take the average of all 3 scans. It'll give you the average of all 3 scans in your calibration. But we're just doing a quick calibration right now. So I would suggest that you save the calibration. So when you hit save button, another box pops up. If I can bring it over here, and you can add comments or change the file name, and you hit save. And this does save the information to your users directory. And if you recall the software, it will load the last calibration file you had. So we're going to hit update. And now we can actually take some measurements using the VNA. So what we're going to look at here is our different measurements we can take. We could take return loss for in reflection mode. We could take reflection mode of phase of the signal. We won't be able to do transmission loss or transmission phase because we're not in transmission load. We can do SWR, and I think this is for the value of the transmission sensor, which I'm not sure if it's available for the Pro, but we have RS, which is the resistance. We have XS, which is the reactance, and we have Z here, which is the impedance of the load. So we're going to choose SWR, and let's choose impedance. So we have a start and a stop frequency. It defaults to at 100 kilohertz to 200 megahertz. And I'm going to leave it there, and we're just going to do in the reflection mode, a single pass. We have a speed, and I'll talk about that in a second, what the speed does. So we'll do a single pass, and there we go. If you notice on the scale, it automatically scales the signal from, in this case, on the impedance from 49.8 ohms to 50.2 ohms. So you're looking at you see the line going everywhere, but you're looking at it very closely. So if we turn auto scale off, the line disappears because it goes from 0 ohms to 3,000 ohms. So let's change it to, let's say, 100 ohms or something like that. And there you go. You can see the signal. And what's great about the software is, there goes my camera. Let's put that back up there and try to save ourselves here. And there goes the camera again. Let's just turn the camera off. That'd be much better, wouldn't it? So what's great about the software is you can put marker points, up to 4 marker points. So there's one. You just click on the line. And if you hold down the shift key, you can click 2. If you hold down the control and click with your left mouse button, there's 3. And if you hold the control and shift button, you have your 4th marker. So you could see all 4 markers right here on the screen and the difference between the marker 1 and 2. And what's great is if you highlight something, it will allow you to copy stuff to your board or turn them on, turn the markers off. So if we look at marker 1, it's at 12 megahertz. And if you use your mouse wheel, if you have a mouse wheel, center mouse wheel, you can actually move the frequency around. So if we go down to like 3 megahertz or 4 megahertz, you'll see that we got a 50 ohm impedance with an SWR of 1.0 to 1. And if you notice that for all values across the board, you got 50 ohms and 1.0 to 1 SWR. So that tells me that the little 50 ohm calibration slug works. So that's a great thing. In transmission mode, when you go to transmission mode of the software, it's going to want another calibration. So when we go to transmission here, don't get, like some people go, well, I already calibrated the unit. When in reality, you didn't recalibrate the transmission side of the unit. So let's create it. Let's do that for you right here. Let's get the video back up here. See if I can get this camera to not knock over for a change. So we're going to take the DUT thing off here, and I got the transmission loop. I'm going to hook that up. I try not to bend, modify, or or move around the cable too much. I kept it the way that I received it. I didn't buy this unit new, so I'm not sure how the cable came. I'm not sure if it was a straight piece or a curved piece when I got it, so I can't tell you that. But there it is. It's hooked up. And we're going to go to calibration here. Go to calibration. We're going to create a transmission calibration. And on the transmission side, you'll notice that the one that wasn't active in reflection is now active. So it says, oh boy, I missed a step here. It says, let's take this back off. That's my fault. See, that's what I got. Okay. So it says read open. So I got the open stub. I think nope, that's the short stub. Got the open stub here. Hooked up, and we're gonna do a measurement, and you'll see the phase all like that. That's sort of how it looks like in the manual. And now we're going to connect that little jumper that I already hooked up here. I shouldn't have hooked up. I like to go in the order from left to right. I'm not sure if I did this measurement first and the open measurement second, if it would make any issues come up. But there we go, and we're gonna read a loop. There we go, and we're gonna save this one as well. That comes up. We're gonna hit save. You already see the calibration from earlier, and you can save all different types of calibrations. For example, if you're using SMA cables and you want or terminated with SMA connectors, and you want to calibrate from the end of the cables, or if you have a bunch of adapters or attenuators hooked up to it, it allows you. I'm not sure if you can calibrate with the attenuators in line, but it just allows you to have all different sorts of calibrations files. I tend to calibrate the unit whenever I hook it up to the computer and use it. So we're going to update, and now we're ready to measure the transmission loss and phase. And if you notice, it's just giving me pretty much 0.01 transmission loss in dB and a phase of almost 0 degrees. So it tells me that this unit works. So now you can start making transmission and reflections measurements using the miniVNA. So for example, let's take off this loop here. For example, I'm going to hook up an adapter. Okay, and I'm going to hook up the other 50 ohm terminator that I use. And we'll see what this measures. It's going to probably measure different because it's a different source. So we're in reflection mode, and I got a start frequency of 100 kilohertz and a stop frequency of 200 megahertz. And we're going to do a single pass. Now, I mentioned the speed, and I'm going to show you what free run and speed is. Free run allows you to make constant measurements. It just keeps looping the test over and over and over and displaying the results. And then you have speed. If you want to make fast tests, we'll go to 8 and we'll hit free run. It will keep looping. Let's change the SWR, and let's change it to impedance here. And if we do a free run, or let's do a single pass at 8, and we'll do free run, you'll see that it through the software it keeps doing the test over and over. So if I put my hand on it or something, you can see slight changes. It's not the best thing to show you this on, and by going fast with the speed is you're getting measurements, but they're not as accurate. So let's click on free run, and if you go in the negative speed, it will actually do multiple scans. If we do single, you'll see that it says job 1 of 4. So it's going to measure 4 times and give you a average of all 4 transmissions. And if you see that it's slightly different from the 50 ohm slug that comes in the calibration kit, it's pretty close. So that makes me happy, and it just sort of triple confirms that the unit is working. So that's the software. Some other cool feature. I'll show you some other cool features that really quick here. You have a generator which uses the DDS chip that's inside of the unit to generate use it as a frequency generator. So that's a pretty cool thing. we have a cable length measurement tool, which is great. All you got to do is hook up a cable to the DUT port, and if you know the velocity factor or you know the brand and model number of the cable, it has many cables listed on here, you can actually measure how long a cable is. So if you for somebody that has a lot of coax or a club station or port, for a field day event, you could test the cables out before you hook it up, and you know for a fact that the cable is at least working. Because let's say there was a break in the cable, this would sort of tell you that there is a break. If you have a 100-foot cable, or you have around 100 feet and it's only measuring 50 feet or whatnot, it will tell you that. So that's a great thing to have. And as I said, you can do this with your Android phone or a tablet. There's some other tools here that I have yet to mess around with. So that's that. And you can also export all your findings in Z-plots. You can do an XML a spreadsheet or Excel file, I'm sorry. You can export the S parameters, or you can export a picture or a PDF report. There's some other cool things about this software. You can generate Smith charts if you're very good at reading a Smith chart. You can do just that. You can print these out. You can also save these graphs and later call them up as reference. You can check the battery life of the unit. You can also, as I said, change the scales, move the markers around. There's a lot of things this thing is cool. It's pretty cool software. And as I said, I haven't had much issue with it. And I would strongly suggest, though, I found out that if you hook the unit before starting the software, it makes things a lot easier. You can, unhook it while the software is running and try to do something with it, and you'll get an alarm or something that, there it goes. And you could hook it back up. But if you do that, you would want to go to the analyzer and hit reconnect. And there we go. It's reconnecting, and it's using the last calibration file we saved. If you did not save the calibration file, it will come, when you reload the software, it will tell you that there is no calibration file because you did not save it. So that's pretty neat. And we did a little measurement here of that load, and we'll go to SWR, and we'll go to impedance. So that's pretty neat. So that's that. I was able to sort of install software, I should say, run the software, connect it to the miniVNA, and do calibration and a couple measurements. So there you go. It wasn't that bad. It took probably about 15 minutes, including installing and updating Java and the FTDI drivers to use this unit. You can start making measurements now, and I'm sure if you ever get one of these or any type of analyzer, you're going to probably analyze everything in your house. And it's a great tool to have in your shack, especially if you have a lot of antennas being used. And I'm starting to collect antennas now, and this unit helps me out, especially when I'm designing my own antennas. So once again, if you liked what you saw here, please subscribe and like my videos. It shows that people are actually watching this, and if you saw something wrong, please correct me. I'm sort of still new at this, and I'll say it with pride. I'm new. But it's a great piece of hardware. I wish I knew exactly what everything means that I'm measuring. But the software is user-friendly. It's the measurements might not be user-friendly, and that's where a lot of hams have arguments about it, saying, well, I don't know what these numbers mean, and it makes them think that's not user-friendly. I'm not sure. I've not seen the older software. I never used the older software, so I'm not 100% sure how these reviews came about. But I'm sure that there's some issues, and they're working them out, or hopefully they're working them out. But so far I had no issues, and I like the unit. And once again, thank you for watching, and hopefully I get some more videos using this thing.